Okay, let's get on with it. The very first day I finished my PhD, I went back to my office, and I had a colleague back then, Mike Hartley. And Mike said, "Oh, you have finished your PhD, congratulations, go and read this book." And I went and I looked at it, and the title said the PhD is not enough. I said, God, I had enough of this PhD, and now I have to read and say, oh, it's not enough. And I must say, this became one of the best things I had ever read about my PhD. And I have read this book probably 5 times or something like that. And I think now has become a compulsory reading for all my PhD students. When they start the first week, they read that. But it wasn't just promoting that book. But I've learned a lot by reading that. And I've tried to summarize some of them. The very first things, once in a while, I think why I got into this job, or why I became an academic, or why I do research. And I think all of us, we had, for different reasons, we got involved in research or getting into academia. Officially, we are curious about science, we want to advance science, we do research. Unofficially, we want to impress our friends and family. We want to, if you're an academic like me, you want to get more funding, add to your CV, make your homepage. You say, I have got this X millions of public money I've spending, publish papers. Or academics, they like to travel to nice places for conferences. Unofficially, we do lots of other things. But when it comes to officially, we say we are curious about science. We will have different degrees of why we want to do research. But probably most of us, one day when we started doing this, we were curious. We wanted to look at the problems. We wanted to really solve new challenges, challenges, and find new ideas which can help to make life better, or be in forefront of science. More or less all of us, we have got involved in research. One day we had this idea. Sometimes over time we forget it. Sometimes over time becomes like just getting more funding, writing more papers. But if you really think about it, go back, at some point we have started all thinking of looking at really to make a contribution to scientific work. But when we do research, either is writing a paper, writing a proposal, applying for, a scientific grant, usually there are a few questions probably we need to ask ourselves. Why is something we are trying to do or something we are trying to publish, why is it important? Often when I read a paper, people say, we are doing this work, we had this bunch of data. I read, for example, we are using a database of, let's say, images. We are applying support vector machine, classify this data, and the accuracy is 90%. That says nothing about what actually the problem was. Or lots of people have done this work before, and I'm doing it because there are hundreds of other people are doing that. That doesn't tell me, again, anything about the problem itself. Sometimes it's really very useful to think what problem we are trying to solve. Again, when I was doing my PhD, I worked on multimedia images, multimedia databases, and creating some sort of storytelling for multimedia. To be honest, I actually never thought of the problem. I just did it because other people were doing it, and there were some probably like famous people were publishing papers, and I just took these papers and I continued doing that without really actually having a pause and thinking, why do I do what I do? What's the reason? It just seems to be everybody does, and let me doing that. And it took me years to actually understand it's very important. Sometimes just pause and think about it, why you are doing this. And saying we are building a system, we are collecting data, we are building a system, we are creating a dashboard, that's going to be wonderful, doesn't tell me anything about the problem. I think if we focus on the problem, what the problem is, could be a very narrow scientific problem, could be a big societal problem, could be a problem we have at work, could be a problem which we see people have in day-to-day life. Doesn't matter the scope, it depends on what you're trying to do at that moment, but as long as that problem is clear. Recently I was reviewing a paper, it was very interesting. The first paragraph of the paper I read was saying they were extracting some information from PDF files, and I cannot tell because that's not a published work, but was very interesting. The first 5 lines of the paper told me that when they were doing another research, they had a problem. And to solve that problem, they did the new work. And I read the first paragraph and actually made me happy. I thought, okay, I understand why they are doing what they do. And Daniel Kahneman has a book called Thinking Fast and Thinking Slow. I don't know if you've read it. He has a very good point. He says if you make people happy, actually it's most likely people follow your suit, means be more generous towards you. And imagine when I read that first paragraph of the paper, it made me happy because I simply understood what problem they are solving. Probably I would have been a little more biased when I started continuing that. And often what happens, myself, I have done it many times and I still do sometimes, when we write papers, actually we leave the introduction to the end and we just say this is the least important part of our paper. We just put some history and recent days advancements in the, usually starts with sentences like that, and we don't think much about it. But actually that's probably the most important part of the paper, because anyone who is going to read and evaluate your work will start reading that paragraph. And if that doesn't tell anything about the problem, then everything will go wrong. And why that problem is important? Because if you say, okay, I'm solving a problem, who says that is important? Saying we are solving an important problem doesn't make it important. You have to justify it. Again, science works based on a scientific process. You have to justify why that problem is important. Saying we are applying, I don't know, X method, combining supervector machine with Gaussian process, we are doing this, doesn't say why is it important, whose problem is going to solve. And just being complex, saying this is a problem no one has solved before, well, could be interesting. No one solved before, maybe because just wasn't any use in it, or maybe actually wasn't the right thing to do. It's very important to be able to explain the importance. Simply, you just need to have some clear statements to say why you're trying to solve something is important. And who will benefit from that? Again, once you have said what's the problem, why the problem is important, the third part is who will benefit from that. Especially when you're writing a proposal, it becomes a really important thing. And there are two ways of looking at it. If you're doing applied research, then that should be probably linked to some economical value, some societal value, you're changing something. Or if more technical, you're saying, for example, this improves the time, complexity, I don't know, will reduce the cost. But you need to identify what are those benefits. And obviously, you need to have some matrix to be able to then evaluate your work in the end against those benefits. Or if it's fundamental research, like if you're doing theoretical physics or math, pure math, probably it's difficult to link it to a societal context or real-world challenges, but you can actually explain, if we can solve this, will change the way we look at the world. And that within itself is a hugely impactful work, but as long as you are very clear why that work is important. And why it is different from other works. Again, when it comes to literature review, it happens a lot. I read and review a lot of papers. You have done it, I mean, many times yourselves. But when it comes to literature review, we usually summarize some work and we say, well, X did this, Y did this, because we want to get on and explain what we are doing, because we are enthusiastic about our own work and we don't want to spend too much time on other people's work, and we just see that a paper needs a section on literature review, a proposal needs some section to say what other people did. There are two risks. First, if one of the reviewers is someone in that area, and if they have an important work and you have not cited their work, I'm sorry, you're going to be in a serious trouble. Second is actually it's very important to justify why your work is something new or is important, because you need to be able to evaluate it against what is done in the past. And you need to come with claims which are provable. Again, it happens a lot. You read a paper and they say, oh, these are the people who have done this in the past and we are doing better than them. Well, everyone can say that, but you need to say why you are doing better than them. Or if you think other works, they are a place to improve, you need to explain what you see as their disadvantages or shortcomings of those works to be able to justify your work. And what type of novelties? The next step, when you have said what the problem is, why that problem is important, how it is different with what already is there, you need to say now what is the novelty of that work. Now you can refer to say, by doing this, that we have changed the way this method is implemented, we are using a completely different method. You need to explain your methodology, how actually that novelty is being put forward, and what that novelty will mean in a simple and understandable form. A colleague of mine, we were writing a paper a few years ago, and I read the paper first. He had written a description. It was very mathematical and was like signal processing. I read it, and I thought maybe I misunderstand it. I read it again. A few times I read it, and what I was understanding from it was we had, let's say, a signal was coming from 5 different distributions, and we were measuring the mean, and the mean was moving, and we were interested in changing that mean. First of all, I thought we don't need all this math. We just can divide the data into 5 fragments and just take the mean and just 2 numbers, put them together, and we will measure it. I read it a few times because I was thinking maybe I'm understanding it completely wrong. But when I talked to him, he said, yeah, that's correct. But then my question was, then why do we write all this math? He said, well, that's the proper way of doing it. I'm not sure if that's the proper way of doing it. I understand some journals are very math-driven or people like to see math, but I don't believe in it. I'm not saying I'm perfect or I haven't done that. I'm guilty probably myself in the past doing something similar things. But I guess if your work can be really solved with something simple and can be explained in a simple format, just explain it. Don't make it too complicated. I think scientists are... there is always this tendency to make it inaccessible to people. Just make it very simple because your reviewers will love it. You make their life easier to read and understand it. And if you think the math is important, put it in an appendix or add it a section, say, this is the simple form. We are measuring 5 means and comparing these means together. And this is the math if you're interested to read, or just skip the math part and don't read it. And then the next part is, why is this challenging? Because there are 2 ways. If someone reads your paper, they want to see you. Usually people find that have gone through a difficult process to get where they are. They want to see you go through that the same pain. If you're doing your PhD, your supervisor wants to see it really became a 3 years of difficult life for you to be able to decide to grant your PhD. Or if you're publishing a transaction paper, people will say, if it comes across it was an easy fix, usually they will say no. You need to justify, to do that work, it was a big challenge. You couldn't just put an easy fix to fix that problem. Or if you're applying for funding and you're asking for 5 million and people read it and they seem to be, it's very simple, they're going to put 3 people and they're going to just collect the data and just do something simple and it's going to be solved. Why should we give them X million to do that? I'm not saying add unnecessary complexity. No, that's wrong. But when you're writing your grant or writing your paper, just really think, what was the key challenges of doing this paper? Or if you're planning for a new work, think of what would be the challenging steps, and then focus on those challenges. And if there are some shortcuts in between to be able to link pieces of your work you are doing to solve those challenges, just be honest about the simple parts. Say, these are the easy fixes I did, and these were the challenging parts, and focus on the challenges, because people want to see, okay, your solution is novel. For industrial patents and things, doesn't need to be challenging, but often for transactions, for some scientific grants, they want to see you are also solving a complex problem, and then you need to justify what are the challenging parts. Simply just a simple fix won't work. Then what would be the impact of work? Let's say you work on an important problem, you know, identify the problem, it's different with other people, you have done something new, novel. What will be the impact of it? Who will benefit eventually from your work? And why that impact is important? Again, initially, in early days, when I used to write grants, for me, this impact and things were just things I never wanted to work on. I always thought, why should I spend my time? And always I hoped someone will take it and will write it for me. But the more and more actually I started thinking about it, helped me to also to go back and think of my problem, think about my problem better. Because if you're developing something and you want to advance science, it's good actually to start thinking who will benefit from that science and what will the impact of that work. If you can visualize your path, starting from a problem, ending up and solving someone's problem, someone's challenge, and impacting something in society, in science, in theoretical science, that will actually help you to go back and reformulate probably your solution well. Just by saying this work will have an impact in, I don't know, reducing crime is not enough. It is important, is interesting, but you need to say why and how it's going to do that. And in many ways, often when you read these impact statements are very generic. You read it and everyone can say the same thing. the difference now comes if you can differentiate your work with some a little better examples, with more tangible, more elaborate explanations, then that will make a big difference. In writing papers, probably this becomes becomes more or less like implicit in your paper. But again, it's important you say, by what we have done, we have changed the way people were looking at this problem before. Or we have, like in the past, if you wanted to do this research, would have taken you twice the time, twice the resources, twice the, the complexity to do that. And the impact of our work is now you can do it twice faster. And I think these are type of things people will find it very, very valuable. Then this less applies to papers, but mostly for grants. You need to be very specific what you need to do this research. Obviously, when you apply for grant, you are looking for money, but that money has to have some resemblance to what you're asking. Often in academic work is you do reverse engineer, you know you're going to get X amount of money and try to justify this. But reviewers are the same. They're coming exactly like you from the same field, and they will quickly pick that one up. Then you need to really think carefully. If that means you're going to get a little less money, it's better than actually being annoying. Someone says, look, they just put some resources because they wanted to have X, Y, or they wanted to have 5 postdocs to work with them. Rather than doing that, start really thinking, if you want to do this research, what resources you want. Got to be even if it's small research you're doing, like for a small scale study, and you're asking for a small amount of money. Still, if you can really think through what resources you need and exactly put that resources, that will give you also, your reviewer, a better view. They will say, oh, this person knows actually what they do. Because if you come and ask for 5 times the resources you need, actually, even if you're scientifically interesting, people will say, oh, wait a minute, actually they don't understand the scale of their work. Or the other way around, if you're trying to solve a complex problem and you say, I need 1 person to do this, people will say, no, it's much more complex than what you thought, and I don't think this is going to be a successful grant because you have underestimated the complexity. Then often these things are, we less focus on them because we are interested in the science and technical work, but they become important when you put them all together to create the big picture of what we do. And what are the tangible outcomes? I never forget, the first grant I wrote, actually I never thought of that. I spent 2 months to write a grant application, and in the entire grant I never said actually what the people are going to fund this are going to get in return. I just thought, my science is interesting, give me money, I'm going to do this research. And no part of that research was said, what is the outcome? Obviously, it's very important you tell people what is the outcome of your work, and if it goes to an industry or more, it becomes more and more now for even the scientific councils, they want to understand what is your technology readiness level when you are delivering the results. If you are doing really theoretical science, probably that will be lower. It's okay, but you need to at least to give some idea what level of maturity this solution is going to get. Or if you're doing close to applied research, you need to say you're going to create a prototype, you're going to create a product, and how you're going to actually deliver that. If you're writing a paper, then in the paper show, if you have, created a software, add some screenshots, add some demos, ideally you need to have some online demos, or if the code can be made available, if you don't have any IP issues, make the code available, make the data available, and make it reproducible. Again, making code available is not just dumping the code somewhere in a GitHub on an open repository, which people look at it and they have no clue where is the beginning, where is the end. The easier you make it for people, is the highly likely your paper, your grant, or whatever it is gets accepted. Recently I read a paper, and they were explaining a software, how it works. They had added a few screenshots, but it was very difficult to understand actually how that software works, and they had 4 pages to write. You can't explain much in 4 pages. And they had 2 small links to some very simple YouTube videos. Each video was 3 minutes, but actually when I clicked that, it was much more clear when I continued reading the paper what they were doing, and completely changed my view. Actually, I became more biased to give them an accept because they made it simple for me to understand. I didn't need to read 5 times to understand what they were doing. The more you make your reviewers' life easier, you make it easier for them to understand what you do, the highly likely they will like it. Other way around, try not to add unnecessary complexity. I wrote a grant last year, And sometimes I do mistakes, and sometimes I do really bad mistakes. And I think it was just a bit of vanity and being pretentious. I added some mathematical formulas that we didn't need. I don't know why I did it. I thought, oh, I need to make it a little complex. What I did, I have to think about it. Actually, the people who are going to review my grant are the experts in that field. They don't need the math. They are interested to see what is the novelty, what problem I'm solving. And that math, there were like 2-3 lines, but completely unnecessary, because whoever reads that grant already knows that. If they've done an undergrad in that field, they would have known that. It was just a bit, was looked like a show-off. When I looked at later on myself, I thought, why did I do that? And exactly that hit a chord with one of the reviewers, gave me like 1 out of 5, means just basically kills it. If the others even give you 5 out of 5, your grant is rejected. Because looked at it and I just think I came across annoying and just got rejected. Sometimes just don't add unnecessary complexity. I'm not saying make it too simple, because if you make it too simple, people say, goes back to my earlier point, if it's too simple, people will say, well, this is a simple fix, why should we fund it? But don't also add unnecessary complexity. Always remember, people who are going to read this, they are experts in the field, they are same as you, and they will have probably, if not better, equal understanding, or maybe slightly sometimes less understanding of your topic. Then if you are trying to confuse them, either they won't like it, they won't understand it, or if they understand it, they will find it unnecessary. In either case, it won't work in your favor. But then sometimes it's just being really straight to the point and explaining what you have done is good. If your work is interesting, if you have done enough, you don't need to make it too complex. It will speak for itself. And don't use adjectives to saying this is a beautiful work, this is a wonderful work, this is a great work. Let the work speak for itself. Let your results speak for itself. And my last point out of these 10 items for when you're writing a paper or grant, the last item mainly applies for grant applications. If you're applying for funding, also start thinking of who would be the wider beneficiaries of this work. Like if this can be applied to standardization, if there are other stakeholders, if in a wider community people can benefit from that. For example, if you're working on a healthcare scenario, you're working with people with diabetes, you solve your problem, you explain everything, and you say, look, I'm also thinking this can be applied to people with heart conditions. Based on some principles you can explain in a few sentences. That usually comes across really good, because it shows while you are very focused and you're focusing to solve a problem, you have a wider understanding of applications and possibilities of your work. Then in the last stage, start thinking of what are the wider audience of your work. Usually when we start doing research or we do work, we are always prepared, we have a problem, we have thought, let's say, about all these 10 steps, and we are ready to go. And we think we're going to do a research and we're going to hit the target, and we're going to write a paper, we're going to submit this grant, I'm going to get this grant, use the money to do X, Y, Z, travel to 5 conferences. We start planning for that, and that's why we get excited and spend our time. But in reality, it's something like that. We fail until we become successful. And if you haven't failed, either you are extremely lucky, or what you do, someone hasn't actually picked up, there must be something wrong with it, or you will fail anytime sooner or later. You should be ready for that, and you should be prepared. Failure is something nobody likes. I don't like it. And it's still sometimes, not sometimes, always I get annoyed when my paper gets rejected, when I have a grant rejected. If you look at my homepage, but at some point I got fed up and I've written a line, this page only summarizes some of my successful work. If you look at my rejections, it would be much longer. And that's true, because often when we look at other people, we think, oh, everyone is doing better than us, because they seem to be, always there is someone has more paper than you, has more citations than you. Whatever you take as your metric of progress, always there will be someone which more or less seems to like you doing better. I don't think you should never think about all those things. Being competitive is good, but just thinking, oh, because I have failed and the entire world is going to collapse is not true. You should be prepared for failures, but the important thing is, what is the recovery plan? Okay, if I got this rejected, if I need to publish, what is my plan? How I'm going to recover from this? If I have submitted a grant and I was waiting that to be accepted, what I'm going to do? If I applied for a job, I didn't get this, what is my recovery plan? important thing is not having failures. Important thing is to having some failures. And often, when I started, I said sometimes I really start think everything is going wrong when I start a new project, or when we have a problem. I find it challenging and we can't solve it. I think, oh, we're never going to be able to solve this, and I'm going to my entire career is going to collapse. Actually, if you wait a little, everything will be fine. I mean, you need, sometimes it's just patience. But you should stop letting that to get into, to make it fear. Like what I'm trying to say, sometimes when things don't work in our favor, we try to find some other reasons, like, oh, reviewers don't like me. In this department, there is someone doesn't like me. Or this reviewer, I was unlucky. This reviewer didn't understand my work. Yes, true, it could happen. Statistically, you will get some, in cases, you will get reviewers don't read properly. They won't review your work. Let's hope everyone reads with high quality. But once in a while, these things will happen. But don't let these things to drive discourage you, or drive, the fears drive you. Start thinking, okay, if this time they didn't understand it, next time I will write it more clear. If this time they seem to be unfair to me, next time I will be better than that. I'm trying to overcome that problem. Not rather than thinking of, oh, they're never going to accept me because they're always biased against me, or they don't like this approach or things. Try to think, well, maybe there is something wrong also with my approach. Let me think about it again and in a different way. Never let the fear to drive the way you do. When I started, when I went and talked, I have to confess this, talked to Nan to do this talk, I was worried because I said, what's the reason? Why do I need to come and give this talk? People will find me pretentious. They will say, oh, he wants to talk about his research. And I was worried about that, I must say. But you know what? I really enjoy it, because I think when I started preparing this slide, it reminded me how much actually I find myself this useful. I don't know whether you will find it useful, but I enjoy it. If I enjoy something doing it, and if I think other people will find it beneficial, why not doing it? Then never worry about what people might judge you, what they might think about it. As long as you think what you're doing correct, and probably looks to be correct, then just do it. Oh, creativity. We hear a lot. I think our society is obsessed with making things always better. We have these phones, we want every year to become better, faster, I don't know, slimmer, smaller, or whatever. It means we are just becoming societies obsessed with making things better. And it seems like a lot of around us, especially if you're in research field, people just talk about creativity. We got to be creative. When I started doing my research, actually, I didn't know what it means, and I found it really difficult, because I went for the first 3 months of my PhD, I read papers, and I was told, if you read these papers, you compare your work, you will become creative, you will come with an idea. I had no idea what to do. I continued reading for another 3 months. I was 6 months down to my PhD. I started writing some codes. There was nothing new about it, and I wasn't creative either. I just went to library, started reading books, and I started panicking. And my model started becoming something like this. I don't know if you know about alchemy. In all times, alchemist tries to combine different material to make gold. It's just randomly, let's put, I don't know, iron with copper to see if we're going to get gold. And it's like, mix it with sodium, let's do this. And my approach to research, like in the first year of my PhD, halfway through, became just like a stochastic alchemist model. I just started reading papers which randomly seemed to be related to my work, and trying to extract some model from X, some model Y, to let's put them together, let's add something complex to see whether this is going to work. And you come across lots of papers, I mean, not lots, but once in a while I read review papers, seems to be like that. Just people putting a series of different things which they seem interesting, and their own merit they are interesting, and they're trying to solve a problem which you have no clue about it. The solution doesn't seem to be coherent, because it seems like in science, if you want to publish something, it needs to be creative. I believe in creativity, but I think a lot of it comes with hard work, and creativity doesn't need to be equivalent to complexity. Sometimes we need to look around ourselves and maybe get out of that very narrow, zoomed work, attention to work, look from a wider picture, and sometimes we can be creative, we can come up with interesting ideas. And sometimes those ideas we are looking around us is just around us. We just need to look for them, and we will find them. One of my favorite stories about this Charles Lyell and Charles Darwin. I don't know if you have heard about it. Charles Lyell was a Scottish geologist. Before his time, when he did geology, people had this idea of this canyons and these mountains have been created with like some biblical storms. Geologists couldn't think of how these canyons and things have been created in the past. Always they had the idea the world in the past must have looked much more different. There must have been some biblical storms created this. Charles Lyell came with this idea to say, no, actually the way the past was is the same the way as it's now. Like all these canyons and things have been created by lots of erosion over time. Like the rivers have gone for millions of years, the same little tiny things has happened, and then have created something like this. It means if you repeat something which with a small effect for a long time, you will have a large effect. And then at some point they became a friend with Charles Darwin. And during the discussion, Charles Darwin started thinking about this problem, and actually that was the idea encouraged him to think of the evolution and the idea of natural selection, because if looked at if everything keeps repeating over a long period of time, we'll start like creating whatever we see around us in terms of biodiversity. Again, his idea actually came from something had nothing to do with his field of work. He was a doctor, he didn't like sign of blood, and he decided to change his field, and the rest is history. He came with the idea of natural selection. Then if you're working on solving real-world problems, your idea should be really broad. Again, one of my other favorite stories is Hubble. In 1929, Hubble published a paper. And he went and looked at, by then the telescopes were accurate enough to be able to give us some idea about the stars and galaxies far. And he looked at and measured the speed of these galaxies getting further than us. Did you look at the light spectrum, and if something moves, the spectrum will change and you can measure their speed. That's beyond the point. He came up with this interesting observation. First, it now looks very simple. He looked at the speed of how the stars is getting further than us, and he noticed there is a constant. If you multiply that to their distance, you can always measure the speed. It means the further than they are from us, the speed of they are getting further than us becomes higher, and that always is a constant value. He was very humble. He called that K in his paper. Now constant is called actually Hubble constant. Very simple. Like people had this telescope images. People by then could measure the speed of the spectrum of light, could measure the frequencies, could actually measure the speed, but no one actually had thought their speed just goes based on a constant value. It was just a matter of some measurements, which the measurements data was there, the star data was there. He just started making the observation a different way. He just looked at this problem, which just seemed to be very trivial. If you have the data, obviously, it's very trivial. And there were around that time, there would have been lots of other people had that data, but probably no one thought the way he did. And obviously, a few years later, a physicist came and looked at this, said, okay, if we have this speed of the stars, let's say if speed is a multiplication of their distance compared to this Hubble, and we know time will be distance divided by speed. Am I correct? D by V. Yeah. Okay, if you want to see when was the time started, because we know their speed and we know the distance. If you multiply them, I'm not going to go to the math of it, but basically if you take this, divide the distance by because Hubble says the distance by this constant will become their speed, d by d will be eliminated, and what you are left with is 1 divided by Hubble's constant. That's the starting of the time. That's when the Big Bang happened. Always when the scientists, they said Big Bang started 14 billion years ago, I just thought they were coming with an estimate, and who cares, 14 or 12 billion won't make a big difference. Probably they say it and we can't measure it. But actually there is a way of very accurately measuring it. Because if you know Hubble's constant, and if you just put what we learn in physics, basic physics, probably if you studied physics 2 weeks, they will teach you T is equal by d by v. If you put this, you will get the same formula, and you will be able to calculate when the Big Bang happened. It's a massive thing. This completely changed the way we look at science. But actually the principle of it is sometimes is very simple. Then sometimes thinking simple, it helps. I don't know, have you seen this guy? Have you heard about him? He's one of the founders of MIT Media Lab. His name is Sandy Pentland. Pentland, sorry. During 1970s, he was an undergrad student at University of Illinois, and I think sometime during his undergrad, he did an internship at NASA. During his internship, I guess his supervisors, they just wanted to give him a project, and imagine this is 1970s, satellite images are not good. They gave him some satellite images, and they asked him to look for Canadian beavers. They're tiny animals, and imagine back then the quality of satellite imaging wouldn't have been really good, and the computers were not that powerful. If you would have asked me to solve that problem when I was undergrad, I would have started looking at the shape of this animal, would have looked at trying to see if I can zoom this picture, would have looked at how I can search that, what would be my accuracy. He took a completely different approach. He said, well, beavers will make dams. These animals, they block the water, and the water starts accumulating behind that. He said, well, if I cannot see the beavers with my satellite imaging, but I can see the water. If I can identify how many of these little lakes I can find, probably I can get a good estimate of number of beavers around that. And that was a really fantastic solution to solve. But if you would have asked me, probably I would have gone through a completely different approach of trying to get this animal here, trying to find it, and would have never succeeded. Sometimes thinking of the problem a little differently actually can make us really creative. And this comes by experience. This comes by trying to, again, look at problem with a different lens. And sometimes not just try to immediately to think the first solution comes to our mind. Sometimes that could be the best solution, but sometimes we need to just step back and look at what are the different alternatives to solve that problem. And sometimes they are very, very obvious things, and sometimes even less scientific ones. Take Twitter as an example. Whoever thought 128 characters, if someone comes and limits you to publish 128 characters and create a website, you can just share that data, will worth sometimes in a few years billions. Around the time Twitter came, the technology was there. Probably you could have given the basic version of Twitter as an undergrad project. People could write that. I mean, I'm not saying the complexity now they have added behind that, but the basic version of it was very simple. But someone thought about it and came with that idea, and people liked it. In scientific work, necessarily doesn't mean that always the most complex solution is the best solution. Sometimes you need the complexity, but don't think of the very first solution comes to your mind. Again, another analogy from the World Wide Web. I did my undergrad when the search engines looked like something like this. The very first version of the search engines was Yahoo, still around. And interesting, Yahoo's search engine was a Unix grep function. Basically, Yahoo used to go and dump all the pages in a server and run grep will search for a string in files. If you have a collection of files, we'll search for a string. And that's how Yahoo used to search for strings. And funny enough, they didn't have any ranking. Whenever they found the results, they just dumped on the page. And crawling and other things were other issues. Then a few years later, around that same time, another website came which very popular, AltaVista. That ceased to exist. I don't think that exists anymore. AltaVista was a little more advanced. I mean, they all followed. I mean, soon, the Yahoo also followed. But AltaVista could rank some of the rank pages. They had like looking at where you write the text. If you wrote it in bold, it was a headline. And they had different ways of basically ranking the pages. And this would have been around the time I was finishing my degree, doing my master's. And we used to use these things, but I never actually thought of how you can solve that problem differently. And interestingly, one more thing is, AltaVista had a problem. The complexity of their search increased if you started adding more keywords. And what they used to do during the peak time, they used to make this box smaller to discourage people to add multiple keywords, because the servers were not very powerful. If you added multiple keywords, made it very complex for their search. And obviously, the easy solution was during the peak time, they used to make this smaller. Then Google came. I know it's a brilliant idea, but if you look at initially what they started doing was actually when people were more focusing on the text, where you write the text, where you put the headline, frequency of keywords or frequency of keywords in collection of documents, they changed the focus on links. because they said if we look at the links, if many people have used Sari to link to a certain page, that means that refers to Sari, and we use that. Then the focus changed from the content of the text, which is still important, to the links, and they started exploiting the links. The rest is a Markov chain Monte Carlo. Most of you can solve that problem, and now you can find the code as like a student project to run that. But that suddenly changed the way actually we use internet. I mean, that completely changed our life, probably, or the way we actually access the information. Obviously made Googlers billionaires. Interesting enough, during the same time, there was another solution which looked at the links. Many others were doing, I'm not saying these two, but these two were the most dominant ones. And the other algorithm was from Cornell, was called HITS. And they had a little different approach, but more or less they were also looking at the links. And I was interested in saying why Google succeeded and HITS, I mean, you don't hear much about it. Why that some solutions in a similar way, they become really dominant and they become very successful, and some they don't. Obviously, there is some natural selection, some luck, some money behind it. But sometimes also your solution needs to have some good complementary techniques behind it. My feeling is, this is my judgment, necessarily is not correct. One of the things made Google also very successful, Google's work was not only page rank, but they also had a good approach to how to crawl the information. Then when the fight was how many pages you can actually crawl and find on internet, and how fast you can go and update the pages, because if page gets updated, you want your indexes to be updated. Google had a better approach because there was a combination of Larry Page and Sergey Brin's work, and one of them worked on deep crawling, one of them worked on ranking, and when you put this together, then created a perfect solution. Sometimes two complementary solutions can, in a multiple of magnitude, can make your work really, really interesting. But the most important thing is when you do this type of work, not to focus on the technique. Obviously, all of us, over time, we will become good at one or two or a number of dozens of techniques, and we tend to use those techniques. There's nothing wrong with it. But when you start focusing on a problem, first think of the problem regardless of the technique. Don't think of, because I don't know, Markov chain Monte Carlo, let's solve everything in the world with MCMC. Think of, if there are other ways I can solve this problem. Techniques, if you're good at what you do, which you are, you will be able to learn a technique. But the problem is more important, because if you solve a problem with the right technique, then that you are really creating an impactful work. And creativity sometimes just doesn't come by just sitting, and obviously the social media and things are the killer, in my opinion, and doesn't come by just sitting in the office and looking at it. Sometimes just doing things differently, thinking differently, trying different parallel solutions, trying to think of what are the other theories. Can I look at even sometimes in other disciplines to see how people solve that problem, and then go back and see whether I can apply it to my work, or simply just doing something different. So sometimes probably when I go running, I have better ideas than sitting in my office thinking about my research, because that gives me probably better concentration and I don't need to look at my emails. You need to find what works for you. What is the best way will make you creative. You don't need, then if you go all the time running, that's not good either for your work. You need to spend some time in the office to write the work, to test it. But once in a while doing something different, talking to different people, looking at different disciplines is good. One thing you have to be careful, don't overdo it. Don't think of now, okay, if I go and read quantum mechanics and I apply quantum physics to my work, it's going to be brilliant, and then you suddenly, I do these things. I get obsessed about something, and then I waste a month of my time reading something, probably interesting, but not necessarily related to work. I think you have to be very careful of keeping the balance. It doesn't mean doing something different, always you need to bring something from biology to apply to your work. Sometimes it works, sometimes it doesn't. It's just keeping your mind open and keeping open to different solutions is always good. One thing you have to be really, really careful when you publish papers is, I put this data into a library, into a software, into a MATLAB toolbox, and I got this result. And that's how it is, and probably is correct. Never trust that. If you think your results doesn't seem to be right, or if you need to really reevaluate it, think about it. Just don't trust because your results seem to be too good, especially if they look too good. Start questioning whether you have actually done very well, tested well. I examined a work a few years ago, and that was related to some experiments. And their results was like close to 98, 99% with some machine learning correct, or detecting some sort of activity. I won't give too much detail about it. And I was thinking, well, something doesn't seem to be right. If your accuracy is around 99%, I would really worry if you have overfit your model. Probably your data, the way you evaluated it, whether you did class validation, which they hadn't. I think the researchers, they had the same idea. When they got the results, they thought it was just too good. Instead of questioning the way the scientific process they had done this work, they started applying it to multiple different sorts of things. Let's say if this was changing the variety doesn't solve the problem. If you think there's a fundamental problem in the work you've done, you have to go and change the process, not just multiplying, replicating the same thing on multiple data sets, which will come up with the same result. Obviously, to get that right, you need to follow a scientific process. Scientists, they like to see other people have suffered as they have suffered to get what they are, whether it's you like it or not. People like to see what you have done. You have followed certain steps. You have really scrutinized your results. You have really like a solid argument related to your work. And there's an interesting saying, science works based on orchestrated, organized skepticism. You submit your work, and then your peers, they're evaluated. They are skeptical to see whether the results are correct, and they will look at your arguments. They are interested to see the procedure you follow to get your results. And if all that organized skepticism came to a conclusion, your work is good, your 3 reviewers, they gave high rank to your paper, to your proposal, your work is going to be accepted. Then to do that, make your work presented in an accessible way. Make it easier. Especially nowadays, people have less and less time. If they're going to review your paper, make their time valuable. If I'm going to review a paper, a journal paper will take me, I don't know, half a day, 4 hours, 3 hours. That's 3 hours of my life gone. Make that time useful. Make me, when I read that, to feel I learned something. I found this interesting. If I disagree, make that disagreement a pleasant experience. Not you read the first paragraph and people have made so many claims that makes you irritated. If you give your paper to a friend of you or someone who can make an unbiased judgment, if that person said, I read the introduction and annoyed me, be very, very careful of submitting that paper. I highly recommend you go and revise it. And always make your underlying assumptions very clear. If you're making an assumption your data is noisy, less noisy, has this certain distribution, make that clear. If you don't make that underlying assumption clear, people will make their own assumptions about your work. And if that assumption is not in line with your assumptions, then the entire assessment goes wrong. And that's why once in a while, all of us, we get papers, the reviewers have written a review which we don't understand. Why they thought I'm doing this, I'm not doing that. But that's because probably we were not very clear in our assumptions. And make your results code depending on what it is available. I think more and more journals will push towards this anyways. But if you make your results available, if you make it reproducible, you're giving this confidence to people who read your work. Actually, you're very confident. You're confident to put your results because they can go and run and make sure they're going to get the same result. I don't know, you read, there was recently an article in the BBC, I think, was saying actually one of the biggest problems with data analysis and AI, some of the machine learning algorithms, is most of those are not reproducible. When people publish and claim something, you put it and you rerun it and you get different results. It's important to show you are confident and be prepared to answer questions. You publish a paper, if someone wrote later on and asked a question about that paper, be generous. Answer as much as you can because you will make friends. And those people sometimes in future will be really, really helpful. That leads us to be generous in research. All of us, when we create something, it takes time. We have spent a lot of sleepless nights. We have put a lot of energy. And it seems like, why should I put it to other people to use it for free? Why should I give it for free? I think sometimes if you want to create science and you want your work to be used, maybe that's the best way. Actually allow other people to reproduce your work, be able to actually take your work to a product or whatever it is. Obviously, you need to look at what IP you want, what protection you want for your work. But the best is actually, if you keep it closed, sooner or later someone will do better than you. Anything you do, the best science you do, it's just a matter of time. Sooner or less someone will come and do it better than you. It's not your choice. You want to sit on it or you want to open it and give it to people. And my feeling is, of course, I'm not saying put everything for free, give it everything away, but in the right terms, think of what would be the best way of sharing the knowledge you have created. And be prepared once you have given it away. Now everybody knows equally as you do, then you've got to do something better. And this will be always a drive for you to do something better, and you will start thinking of better things. If you did something and you really became a hit, it was really interesting, that's really good. Try to continue that, but don't make that your only legacy. Don't say, okay, I wrote a paper, I've got 10,000 citations, I don't need to do anything else, and for the rest of my life I will just write iterations of that paper and cite my work again. Well, I don't know, I recommend try to think, if you could do that, I'm sure you can do multiple better than that in future. Try to do other things. When you work in places, any questions? Am I going too fast before I continue? Any questions? Shall I continue? Okay. When you work in an organization, anywhere you work, some places are better than others. Within an institution, some departments will work better than the others. But sometimes when you work in a competitive environment like science, people come to science because they're competitive. They want to do new things. They want to be better. They want to just progress. And that competition will create conflicts. Sooner or less, later, you will have some conflicts. The best thing is try to stay away as much as you can out of this institutional conflicts. Sometimes managers, probably less here, will make decisions which might not be in your favor. And sometimes that's how it is. You try to find what is the best thing you can do with what you have at that time. And be prepared. People will have different opinions. You have to be willing to discuss and work with people who have different interpretation of your work, different levels of the way they look at the problem. But if you're getting into a collaboration, always think of a healthy collaboration are between people who bring values. Either you are working with someone more senior, you're going to learn something from that senior person, and you will contribute to some of the work they do, or you work with someone who has equal skills like you, is your peer, someone is doing research which can be complementary to you, and you think if you put these powers together, you will create something interesting. The worst type of collaboration is someone you think, well, I have to work with for non-scientific reasons, or sometimes it's good to establish links. But if you're working with someone who is not, you think, bringing really scientific value, sooner or less you're going to get into trouble. Sooner or less, either you're going to go too fast, you're too slow, and you're going to have discrepancy in your work. All this will create conflicts because you think I'm spending too much time, they are spending too little time. Always think of your collaborators are the most important thing to make your work very enjoyable. Over time, when you start your work is difficult. When you do a postdoc, you really apply for a job and you get someone you really don't know them well. Well, you can study about their work, their group, but usually you get an hour of interview, meeting people, and sometimes you don't have much choices you want to take. But the more you go, you will have more and more options to choose your collaborators, to make friends in scientific community. Try to make good friends, people who you really enjoy working with, people you have met during, I don't know, your PhD, during conferences, and keep those links, because those are the people who actually will help you to enjoy and do really interesting work. Finding a good mentor is really, really helpful. One of the best things happened in my academic career. When I started my postdoc here, I was asked to run a small conference. And we were looking for a keynote speaker. One of my colleagues told me, why you're not inviting, there was a famous guy in the field we were working, why you don't invite this guy? And I said, oh, he will never accept it. He said, well, there's no harm, write an email and say, we have this conference, would you come and give a keynote? And we wrote to him and he replied the next day, and he came. And we met, and He really helped me. I mean, he introduced me to different groups. A few times we have written like special issues together. Completely changed the way I was approaching the scientific community. He's a generous person. He likes to put you in contact with people who think they are interesting. He would like to see other people doing interesting stuff. It's very important you find a good mentor. That could be your supervisor, that could be someone you meet at the conference. If you're doing a postdoc or a PhD, you have to be very careful with that. If you find someone, you come and your supervisor said, I have found a mentor, now I'm going to listen to my mentor, not to you, oh, that's not a good thing. But there are ways about it. I mean, you will find your model around that. But it's very, very important to find a good mentor. Your supervisor obviously could be a really good person to do that. And that's why when you go to conferences, always the conferences are often in nice places. We like to go out, we just give our talk, and I do that sometimes. And I'm tired, I don't want to talk. But actually it's good you go well prepared, ask questions, show you are interested in. And several times happened to me. I have met really, really interesting people during conferences. I've got grants, I've got collaborative work, projects. It's just numerous times that's happened to me. Try to use that time really well. That's why when you go and give your conference talk, don't sit, okay, I've traveled all the way to Hawaii, I need just to give this 15 minutes talk and I'm done and let's go. It's good, enjoy your time, but be well prepared. If you have 15 minutes to show your work, be the best. Be someone when people sit and enjoy and like, you say, oh, I saw that person who presented it. Later on, if you apply to their lab for a postdoc, they will remember you. Next time, if you want to go for an internship, they will remember you. Next time, if you need a reference letter or something, you might ask them. It's really, really important. You will find it really helpful. And communications. I think this is probably, if you want to take one thing out of this 2 hours, this is life-saving. Never send an angry email. Many times I have been really angry and I've wanted to send something to say someone how bad this is and things. I have gone home and I said, I'll write that email tomorrow. And the next day, actually, that concept didn't matter at all. I just thought I found the idea funny. And in a few occasions, I have written an angry email with no exception, and I'm not exaggerating, with no exception, every single time, even if I thought I'm right, I have regretted it. Just don't send it. Email is the worst way of communication, especially if you're angry. And if you think you're angry, write the email. If you really want to write, just don't put the receiver's email address, because by mistake you might click send and it goes. Just don't put the email address. Write it, save it as a draft, wait for 24 hours. If you didn't change your mind, well, you will change your mind, hopefully. It's just sometimes if you wait enough, sometimes situations are not as bad as they look like. But the way our brain works, it's just a combination of signals we get in our brain sometimes presents the situation worse than what it is. Sometimes we feel the situations are, look back like a year ago, think one of the worst things you were really stressed about it. Often many of them have been resolved. You had, I don't know, like 8 months ago, I had a rejected proposal, made me really, really angry, really upset. Now when I think about it, actually it's funny. Why should I? I mean, I have had many accepted ones. I had one rejected one. So far, who cares? Just avoid the temptation. And never threaten to leave your job unless you have a confirmed job. Means confirmed, I mean like you have signed the contract. Never come and say, I'm going to leave. Because if people take you, say, okay, go, you might get into trouble. If you have decided to leave, it's okay. I mean, first, leaving good terms. You never know. The most annoying person you have met maybe has some underlying conditions. Maybe sometimes you don't know people's lives. The most annoying person you have seen in 10 years won't be the most annoying person in your life. Then why you are destroying? Try to have, leave gracefully. Okay, I'll put it this way. And be a decent person. It doesn't matter how people treated you. If you have really made your mind to leave a place, first, never tell anyone. Never. The temptation is you're angry, you want to go, and you want to say, you know what? I don't like these people, I've got a job, I'm going to go. It's okay. Just wait for that for a few days until you have signed the contract, and then go and say, I want to go. It doesn't happen here. But if you've decided to do that, then try to leave as nice as you can. It doesn't matter whether people will understand it, whether people appreciate it. A friend of mine had a massive conflict with their manager. They decided to leave. And during the day he left, he got a box of chocolate and a card, and he left it with his boss. And he left. He even they didn't see each other. They will never speak to each other anymore, ever. But at least you feel, you go back 10 years from now, that person will look back and say, well, probably that I did the right thing. I'm saying the most annoying person in your life now, 10 years later, won't be the same. Personally, I'm very bad at this one. I always say yes. Anything people ask me, well, will you come and give a talk? I say yes. Will you write this? I will say yes. As we speak, I'm on the record. I have promised a colleague of mine who is really matters to me. I'm saying this because I can show it to him. I have promised to write a paper for him, and I'm 2 weeks late. And they wanted that paper 2 weeks ago, and I've written only 2 paragraphs. Simply, I just said yes without thinking how busy I am and how many other things I have. Be prepared to say no. Or if you're trying to say yes, just a little pause and think, do I have time for this? Is that really important? Important to me, important to someone who I care, important to the community I am. And if it is, then try to prioritize, because the more and more you get involved in science and research, you end up doing 1 million different things. And if you don't prioritize, you will end up with having lots of things. If you're doing your PhD, your supervisor is a busy person. I have this tendency, I walk, and the first person I see in the morning, if I have a task, I say, okay, can you please do this for me? And I always say, try to avoid me the first day in the morning, because if I have something, I will ask the first person I see. And people, they want to ask you for help and favor. Be like, do this, do favors to your supervisors and your colleagues or whoever you want to. But always think, do I really have time? A colleague of mine, he has a really interesting approach. I really like it. Every time you ask him to do a favor, he says yes. But at the moment, I have like 5 different things. Which one first you want me to stop? I'm happy to do that. I have these 5 things. Which one is your priority? I will stop it. Or I can do this for you in next 2 weeks. Or I just don't think we should do this. It's not that important. And if the person is rational, we'll accept it. If someone is expecting too much, unreasonable, probably you need to revisit the entire relationship. And you need to visit your priorities time to time. I mean, I'm saying I'm the worst person. I'm saying this, and I know I'm the worst person actually doing this. But it's a reminder to myself. You need to look at what is your priority. You got involved in science. You started doing a PhD, a postdoc, an academic job, or whatever you do for a reason. And we get involved into nitty-gritty details of work, and we forget that reason. Sometimes we just forget why we started doing this. I just get involved in too much, how much money I bring, how many students I have, how many citations I get, and that becomes my life, let's say. And suddenly I forgot, actually, I didn't get into science to do any of these things. I don't know, I like teaching, I like doing something else, and try to revisit. Once in a while, it's good to go back and have some reminders to think of why we got involved in this. And always try to work with other people. I mean, even if you like to work individually, if you enjoy your own research, you don't want to be disturbed, still you work in a scientific community, you work in science, and it's good to have good friends. One day they will become helpful. And try to be generous, to help people. And if you're making promises, try to meet, and try to, when you work with people, try to have some targets. One of the things I hate, people say, let's have a meeting and let's discuss. And there is no agenda. There is nothing actually tangible. If you do this, over time, people get tired of you. And that's a really dangerous place to be. If you want to work with people, if you want to collaborate with them, do a little study about their background. Do look at what they do. And when you meet and talk to them, have a background, have a target. And that applies for applying for jobs as well. One of my interesting experiences was once we invited someone for an interview, and the person came, was good, actually performed well, and just like 15 minutes into interview, I asked, how much do you know about our work? He looked at it and said, oh, you are the IoT guy. And I said, have you ever read any of our work? No. Have you looked at any of our web pages? No. And that was it. By then, in 15 minutes, I had made my mind, I don't think that's going to be a good person to work in our group, because if people are coming to a meeting for like an important meeting, like an interview, and they haven't prepared, they haven't really cared about your work, how are they going to be really prepared for that in the next three years to get engaged? But probably most of you have already chosen this. It's probably too late. But if you're applying for a postdoc, or if you're applying for, I don't know, something, if you want to choose a supervisor, always there is a tendency whether you go for someone younger or someone more established. The younger ones will probably work harder. They will be very pushy because they want to put their footprint in science. They want to publish more. They want to be known. And their PhD students will suffer. In some cases. Or the more established ones, each of them, they will have, different people will have different attitude. I'm not saying a younger one is better than a more established one, but you have to really do your study well. And sometimes the very, very well established people, they're actually too busy to supervise. They will give that supervision to their postdocs and things. Again, you need to look at the dynamic of the group you're joining to see whether you're going to get the mentorship which you're expecting. You're going to have the dynamic of how they run their group is going to work for you or not. And if you're doing a PhD or doing a postdoc, the most important thing is finish something. If you ever spend 2 years of doing a postdoc, have something to say. I did a postdoc at University of X, and that's what I achieved. These are my tangible results. That could be, I don't know, publication, patent, software, whatever it is. But have something finished. Often when we apply for this, especially when I was applying postdocs, always was important for me to go to University X. I less thought actually if I go to that University X, the job applying, what will be the finished product I will have within 2 years? Because we get carried away with the group we want to go, and we don't think much about what actually we can get within that time frame. Try to have some finished results. Especially publications are very important. One of the very first things people will evaluate your work, they will go and look at how many publications you have. Or if you're create something which you can talk about it. You say, I've done a postdoc, I've done a PhD for 3 years. The very first thing people are interested in, can you talk 10 minutes really enthusiastically about what you do? Can you just have a beginning and end, what you achieved within that period of time? Yeah, and don't do too much. Giving talks. Don't put too many words. My slides have too many words because I kept it because it's good. I go and read it myself, and I wanted people who later on want to, if they're interested, to read and have some information. But don't put too many words in your slides, because either people are going to listen to you or going to read the words. And like with the speed I speak, probably you cannot read both. You have to either to listen what I said or read that. And that's not usually a good thing, because you basically, people cannot concentrate on what you're saying. And be enthusiastic. Have you seen this guy? Has anyone seen this? His name is Hans Rosling. He works in a Swedish university. A few years ago, he took WHO data, which are World Health Organization's data, publicly available. He created some softwares. He looked at like wealth and mortality. He started looking at from 1920s to 2010, and this software runs and shows how mortality and wealth are related in different parts of the world. The different data, he just put it together. One of the most interesting thing about it, when you look at him, first he's very animated, very interactive. When he talks, he gives his talks. And one of the most important things, I've put the link, you can go and look at his talks. You just look at his face. It's very clear, the first impression I get, he enjoys what he's doing. And that's the most important thing. If people, when you give talks, if they see you're enjoying what you're doing, if they see you're enthusiastic about this, they will be enthusiastic. If I'm not enthusiastic about what I'm doing, why other people should do? They are spending their time, they are spending their Friday afternoon to come and sit, and it's their life, it's their time, it's a valuable time. And every single person sits here, they have sacrificed 2 hours of their life. Then, if you're doing it, be enthusiastic, or if you're not enthusiastic, just drop it all together and don't give talks, just write papers. Naomi Oreskes is one of my favorites TED Talks. She talks about history of science. That's not something naturally I would have been interested in listening to. I had this series of talks, and one day this randomly popped up in my ear, and I started listening, and I loved it. Go and listen. One of the things is, again, you have to have a good story. When you are telling a presentation, anything you present, you need to have a beginning and an end. And that story if you have a good story, people like hearing stories. Everyone enjoys to hear a good story. Even if you have done a very scientific work, you can say why you did what you did, what was the problem, and you make it to a story and say how you solved that problem. And her presentation about the history of science, but she gives a very, very good presentation. And one of the interesting things is she has these cards. Actually, she follows with cards, but it's a very organized talk. It's okay. If you want to have some notes, it's okay to have notes and to help you to follow what you're going to say, to remember it, but just don't read from the paper. As long as their notes helps you to keep you in line with what you're doing, there is no problem with that. Obviously, you need to know your work, be very well prepared. Don't try to impress people unreasonably. Just be yourself. Do your work. One of the worst job interviews I have given, a few years ago, I applied for a job and I was really interested back then to get that job. My biggest mistake was I didn't focus. I had submitted my CV, my research, and they had looked at it, bad or good, they had liked it. And they had invited me for an interview. But for my interview, I tried to be something I wasn't. I prepared something based on actually a work we hadn't published, but I thought that's very impressive. This is going to impress them. And instead of focusing on all the things I said, having a story, having a narrative, I read a book about physics of future because I wanted to impress my knowledge of how you can combine electronic engineering with theoretical physics or some stupid thing, silly. And that was one of my worst performances in any job interviews I have ever given. Because instead of focusing on a story, when I started giving my presentation, I didn't have this narrative. I had my slides, I knew my work very well, but I hadn't worked out this storyline. And in each slide, I was just like I had hiccups or I stumbled, like, what should I say now? How should I link this to the next one? And none of that future physics or quantum physics, none of that helped. No one asked about this because it never appeared in my CV. My CV said what I had. And the one work I was trying to impress them wasn't published and I thought it was impressive. They hadn't seen it. I didn't need even to put it. But someone picked up a problem in that work. And that was one of the worst things. Actually, that problem was we had done it correctly, but I wasn't prepared because we hadn't published that. I hadn't had enough time to scrutinize that work enough. And if someone asked a question, I wasn't prepared to answer that challenge very well. And that completely, anyways, it was experience. You always learn from your experiences. Yeah, avoid self-promotion. Let your work to speak for itself. Each talk you're preparing will have a different focus. If you're doing a job interview, you need to prepare it differently. If you're talking for your colleagues, it will be different. If you're giving a scientific conference paper, it will be different. But try to use your time efficiently. One of the worst things is like a speaker turns up and says, oh, sorry, I didn't have time, I didn't prepare for it, and let's see what we're going to do. That's not really a good thing. People have really sacrificed their time to come and sit to listen to me. And if I say, sorry, I'm not prepared, already I'm telling, look, we're going to waste your time. Even if I give a good talk, I've already have said something which really won't work well. And try to don't go over time. Even if you think people are relaxed, ask their permission first. If you think like you have 20 minutes and you're going to go for 30 minutes, ask their permission to say, well, I've said I'm going to talk between 2:30 and 4:30. Am I allowed to continue 5-10 minutes more? And don't try to be pushy. Because again, respect people's time and tell a good story. Don't say obvious things. Like if your name is there, if your university is there, you don't need to, if you have like 10 minutes to talk, don't say, well, I'm from University of Surrey, this is in Guildford, we are in southeast of England. I mean, people already know that. This is already, your name is there, your affiliation is there. Try to use more time more efficiently. If you're showing graphs, don't show the graph saying our work is better and show 5 graphs. People cannot comprehend graphs in 10 seconds. It's as simple as that. Because we are very close to our work and we look at the graphs and we quickly get what it is, we are assuming other people know the same thing. It's not true. Those graphs for almost all your audience will be the first time they see that graph. Then explain it or add some annotation, say why it is important, which parts of that graph they should focus on. Because if they have 1 minute to look at that graph, they can't comprehend all the x-axis, y-axis, all the variations going on. If a part of that graph is important, just draw a circle around it and say you should look at it. There's always temptation to add mathematics complex formula to say, oh, well, my work is scary. I try to avoid it. Really, unless your math is your field, or if you're run at math, just try to avoid it unless you really have to. And opening to your talk is very important because people will come to listen to your talk. If your opening didn't attract them, they will take their phone and they will start checking their emails. And that's not a good indication. If you start telling a good story at the beginning to grab their attention, that would be something that people start saying, okay, this is something interesting, I need to listen. And that comes with some preparation. You have to prepare, you have to practice and practice. A couple of years ago, we set a template. I did something. I asked whoever comes for a job interview we had to prepare something, a format called, has a funny name, Pecha Kocha, if I remember. That means you need to prepare 10 slides. And these 10 slides, you have 10 minutes to present. And the slides are going to automatically change themselves. You don't need to, you're hands-free, you're going to stand here, you have 10 slides, each minute the slide will go to the next one. And we wrote the instructions very clear and asked my colleagues in HR to send it to the candidates. We had a few people turn for interview, only one of them actually had followed that. And already the others turned up, already they had a negative point even before they started. Because I was thinking, if you didn't follow what we said, if you didn't really listen carefully enough, how are we going to trust you're going to listen to what we need from you for the next 2 years? These things are very important. And try to be as professional as you can. Look at the color contrast. I mean, in the audience, statistically, will be people who will be colorblind. They won't see different combination of colors. They will find some colors annoying. Try not to use very... make it professional. The template you are using, don't put too many logos. Like sometimes the half of the screen I go to conferences is taken by promotional stuff and there is little space. Okay, if your institution is important, whoever has given you money wants you put them there, put it in the beginning, and just if you want to say in the beginning or end, just say and get on with it. People, they are not here to see, maybe a little logo will help, but people are not here to see the promotional material. People are here to hear your story. They are here to hear something new from you, and that's the most important thing. And if you're going for a job interview, indirectly or sometimes directly, tell them how you work, what you have done in the past is going to help them. That comes with a little preparation. Sometimes what you're applying, your background is not necessarily exactly in their field or not exactly what they have done. But if you can link it and say how your expertise can help them to become better at what they're doing, develop better solutions, people really like it. And don't try to oversell it. Don't over-promote it. If you go to a scientific conference, go for a job interview, people, they know something about that field and they will understand if you're trying to oversell things. But being too humble is not good. Saying, oh, our work is just a simple work. No, it's not. If it were simple, you wouldn't have ended up where you are. If it were simple, it wouldn't have been accepted in the first place for you to go and present it. Then be modest, but at the same time, be really confident about what you've done and be enthusiastic. Humor is a good thing. It's making people laugh, making people enthusiastic about what you're doing. Saying sometimes once in a while something people laugh, it's good. It's a very, very fine line. You have to be very careful. I mean, if you are not careful, you could be offensive. You could say something which people might not like. Then good to use humor. Just think about what you're going to say, and you don't need me telling you examples of things going wrong by being humorous. Again, people when they come appreciate they have put their time. Even if it's a job interview, again, people are coming. Even they have to do that because they're going to interview you, they have to spend their time. Appreciate their time. Try to, don't be too defensive. Like when people ask questions or aggressive in conferences or even people come across angry, you try to be calm. You never know. Sometimes like the best actually, sometimes I have asked questions from people and they have become really defensive. Sometimes even the candidates have become aggressive. But actually, back in my mind, I was supportive of their work. Sometimes people ask difficult questions because they like your work, because they want to challenge you, because they have enjoyed listening to your talk and they have found it challenging and they want to challenge you more. They want to see if you can become more better than what you are. You never know why people are asking some challenging questions. Just even if you're aggressive, you don't. Because audience will realize if someone's behavior is bad, you be a decent person and be calm and answer politely and try to logically defend your work, even the person seems illogical. Statistically, once in 1,000 or once in 10,000, you will hear someone in a conference is angry about your work, will say something. Once in a while will happen. You just try to be patient. And in job interviews, you never know. Sometimes they just try to see how you react to that situation. And often that's actually the case. They want to just see your reaction and you just be yourself. Yeah, don't be too aggressive or too defensive. If you've done something good, just defend it. And if they have asked a question you haven't done or bring a challenge you haven't thought about it, say, well, yeah, that's a really good point. I hadn't thought about it. Give an answer which you think is rational, but say, I mean, that could be your future work. If you want to work in academia, you need to create a reputation. You need to have a few work, something interesting. People know you with that work. You go to conferences, I don't know, choose a conference, go every year, every other year, go to that conference. Make friends in groups. The department you're applying, you want to work, study, see what type of people they take. What is their criteria? They like IEEE journals, they like IEEE transactions, they like conferences. See if you want to apply for that job, what people are going to be interested in, and try to create that. Web presence is very important. Any job you apply, people will Google you. And what they come across, what they find about you is interesting. If they find you have a really neat web page, you have all your code is available, your papers, I don't know, your slides, I mean, that gives a good impression about people. And be a good citizen of community. You never know, the people you meet in conferences, people that write and ask you a question, sometimes they will be one day they will be very, very helpful. And if you're applying for an academic job, try to be interested in teaching. I mean, do some TA job, do some teacher training here, courses we have. Do something to show you have some experience. Be willing to talk, participate in some of the teaching activities to create some track record in that area. Try to create a vision. Okay, when you do a PhD, when you do your postdoc, you're working for someone. Someone has a grant, someone has a project, and you are working with that person. But if you want to look for an academic post, you need to have your research vision. And people are interested in getting people who bring new ideas to their work. Either they complement their work, bring something new they don't have, or they make them stronger in the field they are. Then create a vision to say, my vision in this area is to achieve this. This is the state of the art. I'm going to try to make it better. And try to talk about it. Try to let people know about this in your organization externally. That doesn't mean being too annoying or too pushy, but once in a while it's good to talk about your work. If you sit in a corner and expect people will come and find you, discover you, there are hundreds of people like you and I. You need sometimes to talk about it, to present your work, to show people we do interesting stuff. There is nothing wrong about that. You just don't overdo it. And be prepared. Think of what are the possibilities. Even if you're doing a PhD, apply for some travel funding, for summer school funding. There are lots of fundings available for show you are capable of attracting money, funding. Academic institutions, they like that. That's part of their business model. Whatever level you are, there will be something in that level to apply for to get grants. Try to show you are capable of doing that and show you have the potential to do it even better. Sometimes calling people or writing to them is one of the best ideas. Some of my best collaborators are the people actually either have taken the phone and have called them, or they have called me. A few years ago, I was sitting in my office and one of my colleagues from our School of Bioscience, my phone rang and I picked up and someone said, I work in the School of Bioscience. You don't know me. I don't know you. I just looked it up your page and I'm doing something and I'm interested in the work we do. Would you like to meet and talk? I said, yeah, why not? Probably if the person would have written an email, I always have hundreds of emails, would have gone somewhere, probably I would have responded or not, or would have been prepared. But when she called, it just said, yeah, why not? And that actually, we have one of the best collaborations with the School of Bioscience within the field we are working in 2 years' time. Sometimes writing to someone or phoning, depending on the context. Obviously, if let's say you have a very prominent professor in your field and you have met the person in a conference and lives in, I don't know, in Singapore, it's not a good idea to call and say, well, hello, good morning, I'm calling from England and I have this question. Probably people will be shocked. But in the right context, finding the way of actually more direct interaction is a good thing. If you're applying for a job, sometimes maybe it's not a bad idea to write to that department to say, look, I'm a researcher in this field, I've done this and this, and I'm interested in your work. Do you have an opening? My first academic job, that's how I got it. I wrote to the head of department and I wrote and said, look, I'm finishing my PhD, I've done this X, Y, Z, and I'm interested in a job. And they said, no, we don't have any jobs. The head of department wrote back, and a few months later he said, now we have an opening, would you like to apply? You never know who you come across, and sometimes people might not respond, but if you get a response, usually is an encouraging and is a good thing. And if you want to do something useful in academia, stay out of politics. Academia is full of politics. Oh God, I'm on record. It's just stay out of it. I won't explain more. In industry, it's different. You will work in a managed environment. Your industry has a target. You're working for a company. The company has a mission, wants to create X, has a product, has a mission. Whatever their mission is, you will work towards that mission. Obviously, depending on the culture of the community they have, the culture they have in the workplace, they might have some flexibilities. Usually, like take Silicon Valley type of companies, seems to be more relaxed. Some companies will have more specific role. If you're applying for a job, look at the dynamic of that workplace. Be prepared to see what is their value, what they're trying to achieve, what their employees are responsible for that. The advantage compared to academia is probably the quicker to get a permanent job, if there is something like a permanent job anymore, because that industry can go down any time. Similar academia they can close a department at some point, or I don't know. But the chances of like getting a tenure academics takes for sometimes long time. You have to apply for a postdoc, you apply for a lectureship, you're on probation for X number of years. In the US, you're an assistant professor, you need to be promoted, otherwise you have to leave, go somewhere else. It's a bit more complex. In industry, seems to be more straightforward. You go, you have 6 months what do we call it, probation, and then you land on your job, and probably you can progress much faster. And obviously your job description is much simpler. You work in a team, you have a job. In academia, you're a teacher, researcher, you write grants, you manage, you supervise, you do 1 million other things. In industry, probably a bit much more simpler. I'm not saying you have less job to do, but the job description probably is I'm guessing will be, depends on industry, but much more simpler. Publication. Anyways, to be able to land in any of those jobs, you need to write some papers. You need to show your peers you are able to publish. And that's the best way of communicating your work. These papers you write are going to stay for years, probably forever. And whatever you publish, think about it. Like some of my papers I've written in the beginning years of my PhD, I wish never my PhD students read them. When I wrote them, I never thought of that. Like when I did my PhD, I never thought one day, oh, people can go back and read that. But these days, anything you publish is publicly available. Think about it. And at the same time, if you write something really interesting, can have a really magical effect. Don't exaggerate it, you don't need, but just do an interesting thing and write it interestingly. Like write a good story around that. I talked about this. You need to choose the right journal. Obviously, you need to talk to your supervisor, your mentor, whoever, choose the journal. But it's very important publish in the right place, because people will judge the quality of your work, quality of your expertise based on where you publish. And if you set your qualities right, you will move on the right track. Often it's very difficult to find what is the right balance. You need to just work out within your organization. There is nothing correct or wrong I can recommend here. You just try to identify what quality you want to be and publish. Look at what are the level of publication in there and write in that level. And always remember, whatever you submit, people spend time to read and review it. Respect that time. If you show you have written something pleasant, easy to read, with less mistakes or no mistakes ideally, your figures are clear, The style is clear, the template is clear, it makes it much, much easier. The worst thing is if you have the best science and you write it in a messy way and you make it difficult, make it less accessible, and people won't like it. Then the writing is very, very important. Often we focus a lot on creating results, get enthusiastic about what we've created, and we really believe this is the best way of solving this problem. And we write it and it doesn't get accepted. Partially goes back the way how we explain it. And again, a literature review looking at the related work is not just summary of what exists, is looking at and analyzing why what exists wouldn't have solved that problem in the way you wanted that to be solved. Often you read these literature reviews and people just say X, Y, Z did this and this. That's not enough. Say, people have done this, solved this problem before, have done this before, but the way they solved doesn't do the way we wanted to do it. We wanted to do it better, cheaper, faster, whatever it is, and the existing methods don't do that. And avoid magic. It has happened to me. You read paper, and suddenly there is some sort of a magical leap, and then they got the results, and you never know what happened. Wait a minute, just from this step to this step, what happened, how they got that result. If I see that paper, that definitely I'll reject it. I just don't trust. Either there was a mistake or they omitted a part of their work on purpose or not intentionally, unintentionally, I don't know. But if you see that, you just reject that paper. Try not to do that. If you have got the results, explain what steps you took to get there. Because you read the input and the output, just you can't get how they got from here to here. It's not clear. And proofread it. It's very, very important. What you write is, again, has no mistakes. Unfortunately, most of science we come across is about success. People talk about, we tried this and it worked. People put their publication, always they talk about success. They less talk about the failures. But in reality, to get something work, we have done many, many times, we have had many failures. It is very, very difficult to publish a failed approach. If you come and say, we wanted to, enhance the images and we tried method X and we spent 6 months and it doesn't work, it will be very difficult to publish. Actually, I'm in favor of publishing. I've seen a few times some really interesting work because that will tell people not to do that again. Because people will know if you do this, some people in the past have tried and it didn't work. Unfortunately, most of the scientific community don't like that. They like to see the successful work. But if you do write a paper, a dedicated section, talk about your experiences. Say, we also tried method XYZ and we had this problem. That led us to try this method. That again will back up your methodology, will give more confidence to people. They knew what they did because they tried a few other methods. If they had questions, have you tried method Y? You have already answered that questions. If you're writing a PhD, talk to your supervisor. My recommendation to my students is just have a section, says lessons learned, and talk about the failures you had. I don't mind if that section becomes 2-3 pages. It doesn't matter. That's actually the most valuable, probably not the most, but one of the most valuable parts of actually someone's PhD, because you learn what methods they tried, what approaches they took, and it didn't work, and will give you better ideas about that field. Again, make sure your claims are reproducible. In future, especially people want to try it, and don't be tempted to exaggerate your results. That's the worst mistake. That's just and acknowledge other people's contribution. If you have asked someone to review your paper, just as an acknowledgement. If someone funded your research, someone helped you in your research, answered questions, do acknowledge them. Anything you write, got to a paper, got to be a grant application, a presentation you give, anything, think of your audience. Think of what is their interest, why they should be interested in that, what is their priority in that field, and present it in that way. If you're writing for a transaction, what is their interest? What is their priority? They want to see solid science, they want to see solid results, right, based on that priorities and so on. If you're applying for a fund, look at what is their key priority to fund the research. Just I'm doing something interesting is not enough. Align it with people's interest as well. Be good collaborators, but as I said, be prepared to say no in a polite way. Say, yes, I would love to do that, but at the moment I'm busy. Can you give me a couple of weeks or a couple of months or a couple of years, whatever. And define your priority. What is your priority? You get a postdoc job, you have 2 years, 1 year, whatever. What is your priority? And what is the place you have joined, what is their priority? Only if you follow your priority, you leave their priority, that relationship is not going to work very well. Try to align and make sure these two priorities are aligned, and then define within that scope what you're going to try to achieve. And try to meet interesting people in your field and your discipline and outside your discipline. Create a good network of people. I mean, almost everything I've done in my academic career has been done by collaborating, working with other people. And the friends you make, the collaborators you have are the best thing. And never underestimate or think I'm better than these people, I don't need that, I don't need this, I'm good at what they never think like that, or never think people are not important. That's the worst mistake. Always be generous, again, going back if you have time and if you have the right priority for that. For your publication, you have to have a target. Usually, often we work very well with deadlines. Set some deadlines. If you are interested in a conference, see when is the deadlines. If you are interested in applying, going to certain conferences, look at when they publish. Have a few of them. Try to make some milestones in your work to be able to publish. If you're planning to write journals, that's more difficult because journals often are open-ended. You're submitting anytime you have to work. But have a deadline. Say, I'm going to write that paper within the next 2 weeks, another 2 months, or whatever it is, and try to meet that. Apply for funding. If you started a PhD, I guess apply for travel funds. If you're a postdoc, apply for fellowships, smaller funds available. If you're applying for academic, apply for whatever available in academic. Go back to the 10 questions we had earlier and see whether your work applies for that. If you're within the industry, within your organization will be funding to your department, try to attract some funding and do work. But that funding got to be related to an aim. Because if you get money, you don't produce results, that's going to get back and hit. Be prepared once you have that funding to produce good results, which can, in a chain effect, help you to get to the next level. And always go back and look at your goals. Lots of people have helped me. I've learned a lot from my students writing this and doing this. And lots of interesting sources I've come across. Obviously, that first book I showed. And some of the things you think is impossible, this is a picture from 1950s, if I'm not mistaken. And in 1950s, this looked very ridiculous. Now there's actually people here working on it. I don't need to tell you. Then sometimes when you think something is impossible, you never know. If people really work curious, if they work hard, and if they become creative, actually some of the things which looked completely impossible will become a reality. It's just a matter of time. Thank you very much. Hope you enjoyed it.